Oh, I need to bring this over here. Okay. So what are we going to do? What are we going to do? How are we going to do it? Okay. So we are going to be talking about the abacus and we're going to be counting. When we count, we have 1, 2, 3, 4, and then 5. All the top bead has a value of 5, and then we have 6. So anytime the beads are touching the horizontal bar, this is the horizontal bar, this is the horizontal bar, this line that's right here, this line tells me that these beads are being counted. Because these beads are being counted, they are counted, so this is 6. All the top bead has a value of 5, all the bottom bead, anything underneath, this is what we call lower here, anything lower has a value of 1. So if we do 5 and then 1, this is 6. And then we have 5 and 2, this is 7. 5 and 3 is 8. When we squish them together onto the horizontal bar, that is what's being counted. Notice these beads are not being counted, so these are not considered as part of the counting. So these are 0. However, this is counted. Why? Because they're touching the horizontal bar. The horizontal bar is what keeps. It was a low key. Ha! What? I was low key waiting for you to go live. Ha! Lofty. Really? I'm so sorry. I was just like, oh, I don't know who's. Okay. Hi. Welcome back. Yeah, okay. So we're talking about 8. We have 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. And then what is after 9 is 10. After 10, right? How do I know this is 10? Just as we write our our ones and our tens, this is 10, 1 and a 0. That's how we write 10, 1, 0. Does that make sense? Anyways, okay. Let me know if anybody has any questions. Oh, there we go. Yeah, okay. So, we have our number. Let me see if I can find my pen. So we have 11, which would be like this. 10, 1, and 1. So that would be 11. Okay, after 11, we get 12. Now I need to erase it. We have 12. That would be 12. And then we have 13, 14, and then 15. After 15, we have 16. Does that make sense? So if I write it, we have 16, 1, 6. That's how we read the abacus. We have 1 and then 6. Lovely, hey Trey, thank you so much for the rose. You're back again. Lovely, do you have any specific questions? Because we can jump right in since nobody else is talking. And Trey, do you have any questions? Let me know. We can continue on, but I can just count. Or we can do some adding, subtraction, multiplication, or division. So let me know. Let me know if you have any comments or questions. Okay. Can I demonstrate division? Yes, let's do that now. Are we ready for division? We can do it. Okay. We're going to do some division on the abacus. We're going to jump right ahead. Because nobody else is commenting. So if they don't comment, then it is what it is, right? All right. So the first thing we're going to do is we're going to get a question. Division was the bane of my existence back in the day. Hey, Dano, we are going to do. You're going to love it. You're going to love it. It'll be easy. On the abacus, though. Hey, Artsy Hen, 24, 27. No, those are all division. Those divisions wouldn't be really because it's not bigger. Those would be like taking away. Okay, what am I saying? Those are still division facts. When we talk about it, it wouldn't be as significant. What we would be doing would be this one. So 84 divided by 3. That's what we would do. The reason why, because we know that 7 times 21 divided by 7 will be 3. There's really not really much that we're doing here. And it's the same thing with 24 divided by 3. 7, and this would be just 8. So this is just a math fact. Can you do division to teach kindergartners? Yes, but they have to know the multiplication facts first before they go into division. And I do have kindergartners that do go into division, but they still have to understand multiplication. if that makes sense. So this is what we're going to do is the basic division. And why? Because we know how to do this. The question is we have to figure out how many digits there are. When we know how many digits there are, because there is two, oh, where's my labels? My labels. I got to find my labels. We have our divisor and our dividend. And what we need to do is we need to figure out our place value. The reason why is so then we know where to put our divisor is here and our dividend is over here. So we have 2 dividends and 1 divisor. Artsy, did that make sense? So what we're going to do is we're going to take away 2 digits. It's 84. Take away 1 digit, which is the 1 divisor. So 2 take away 1 is equal to 1. So we're going to start in the ones column. This is where we're going to start. Because we're going to start here, we're going to place our dividend. So we place our dividend 8 and then 4. 84. When we look, now what we need to do is we need to do a comparison. Lofty, are you still with me? When we do a comparison, we need to figure out our divisor and our that was wrong. Our divisor and our dividend. Does that make sense? So our divisor is 3. Our dividend is 8. So who is bigger? Is our dividend bigger or is our divisor bigger? I'm going to go slow. So let me know if I'm going too fast. Our dividend, correct. Our dividend is bigger. So I'm going to put I'm going to put the greater than sign. Now, what does that mean? When the dividend is bigger, when the E is bigger, the dividend is bigger, we want to skip 1, eat 1, which means subtract 1. Why? Because this is a rule. Just hands down, it's a rule. When the dividend is bigger, the rule is to skip this column, so we're going to be over here, and we're going to subtract 1 column. The question now turns into 3 times what is equal to 8 or less. The reason why we say less is because we want, hey, Jose, welcome back. We're out here. Oh, cool. We're talking about division. And so what we're going to do is, the reason why we want to say or less is because we know 3 doesn't go into 8, but we want to get to as close as possible. Hey, Rod. So the closest we can get was 3 times 2 is equal to 6. So I'm going to add my 2 as my answer. Yes, Lofty. I'm going to add my 2 as my answer. Remember, see, I skipped it. Let's divide. So I'm going to skip this this column, and I'm going to add my answer here. Now, what do? I have to take away the 6, right? Just because I have it here doesn't mean I do anything. Yes, I got to do something with the 6. Thank you for joining. Okay, so I'm going to take away the 6. Does that make sense? I'm going to take away the 6 from the dividend. I'm going to change a different color just so we can keep track. Now, we don't go back to this question because the dividend has now changed. We notice that our divisor is still 3, but our dividend is now 2. So if our dividend is 2, who is bigger? Our divisor is bigger. When our divisor is bigger, we have to actually find out 2 digits, 2 columns. Does that make sense? So now what we're going to do is we're going to take 2 columns and we're going to divide it. Because our divisor is bigger. See, this is the conversation we're having with our abacus. This is the conversation that we're having with our question with the abacus. So now, what do? These are the 2 digits. These are the 2 columns that we're going to utilize. So the question is, 3 times what is equal to 24 or less? 3 times 8. So I'm going to add 8 as my answer, and I take away 20, and I take away 4. Did that make sense? Dano, was that all right? Was that easy or was that hard? Is that all right? Are we okay? I know I jumped ahead. Hey, Melinda! We're doing division already. I'm kind of following. We can do another one. Let's do another one. We jumped ahead because Lofty wanted. I'm lost. Okay. Well, that's because Jose, you came in the middle. We have to start from the beginning. Let's start from the beginning again. It was funny. Lofty wanted to do division right away. I did like not even counting. All right. I'm still doing subtraction. Yeah. You can do division. You could do division. Okay, what we're going to do, we're going to start over. We're going to start over. Okay. So let's take a new question. All right. We do 45 divided by. So 45 divided by 3. The first thing we're going to do is we're going to find our starting point. To find our starting point, just like multiplication, but this time, instead of adding the digits, we're going to subtract the digits. To subtract the digits, it's the divisor and the dividend. So our dividend is 2, and our divisor is 1 digit. So we have 2 digits, take away 1 digit is equal to 1. So that is where we're going to have our starting point. Does that make sense? Are we all right? We're tracking like a horizontal bar? All right, we're okay. So what's going to happen, I'm going to clear my abacus, and I do 1. So this is where I'm going to have my abacus. This is where I'm going to have my answer. My answer is here. So I need to put my dividend over here. I'm going to add the 4 and 5. So I have 45. We're okay now? We're still okay? So now what we're going to do is we're going to compare. We need to compare 1 digit from the dividend and 1 digit from the divisor. We do not compare both digits. We only need to compare the 1 because understanding this comparison, then we know what we need to do. So we have our question. Here's my chart. Is my dividend bigger or is my divisor bigger? My divisor is 3. My dividend is 4. My dividend, exactly. My dividend is bigger. So when my dividend is bigger, I'm going to skip 1 column, subtract 1 column. So I'm going to write it again. Skip 1, I'll say eat 1, which means subtract 1. So because I'm only going to take the 1, and this is the column I'm going to skip, yes, this is an abacus. I think it's specifically a soroban. Yes, you're right, Tim. Exactly. This is a soroban. This is a Japanese-made abacus. The Chinese-made abacus is a swapan. I can't even say it right, and I'm Chinese. All right. So the first thing we're going to do is we're going to figure out 3 times what is equal to 4 or less. 3 times 1 is equal to 3. So thank you, Jasmine. So I'm going to add my 1 to my answer. I go to my dividend and I take away. I take away 3. Are we following? Are we tracking? Are we okay? Jose, does that make sense? Lofty? Thank you so much for the share. Are we okay? Wait, I think you get it now. Good. Yes, Melinda. Okay, good. Good, right? So I know I talk fast, so I have to make sure, and I want to make sure there's feedback to understand where we're doing. Okay? Now, we have to compare again. We cannot look at our question anymore. We have to look at our dividend that's on our abacus. That's why it's critical to subtract on the abacus. Hey, Monica. Does that make sense? So now the question is the 1 column is 1. So that's my dividend. My dividend is 1. I should change to a different color. I'm going to do black. 1. My divisor is still 3. Hey, Monica. Welcome back. Divisor. So who is bigger? My divisor is bigger. If my divisor is bigger, I know, hey, Blake, I'm going to take 2 columns instead. Because my divisor is bigger, we know we're going to use 2 columns. Dano, are you with me or you've gone? So what's going to happen is my question is 3 times what is equal to 15 or less? I think Dano left. Aw, sad panda. All right. So 3 times 5. Yes, Lofty. Yes, thank you, Melinda. Take away 15. Take away 1. Take away 5. And our answer is, what is our answer? After the fact, Alex. Welcome. Thank you, Aaron, for sharing my live. 15, exactly. Does that make sense? So what we just did is we divided. Thank you, Jasmine. Thank you. Thank you. So this is the answer, 15. Make sense? We can do some more. I mean, I have a whole bunch. But I don't know if there was some people. So artsy hen, does that make sense? And Picasso Dali, did that make sense? We already know how, we should know how to do 24 and 23. That's kind of easy. So what we do is we do a little bit more. Hey, Anders, I came a bit late. Can you walk through it one more time? Yeah, I can do it again. Yeah, we'll do it again. Let's do it again. I understand it now, right? So we take it. Yeah, let me do another one. But I don't know if artsy hen and Picasso left. Okay. Ander Dingus, do you know how to use the abacus before I continue? Before I continue, I'm going to talk about how to read the abacus. So Krista, after we count the abacus, we'll go into division again. So we do 1, 2, 3, 4. Anytime the beads are touching this horizontal bar, we have 4. This is being counted because the beads are in contact with the horizontal bar. So when we look at 5, the top bead will always be 5. So we have 5 and then 6. When we squish them together, this is 6, and then this is 7. 5, 6, 7. And then we have 8. 5, 6, 7, 8. And then 9. 5, 6, 7, 8, 9. So when we squish them all together, this is 9. This is also 9, but now we start talking about place values. So this is 99, just as we did this. So if we looked at the ones, our tens, and then our hundreds. So when we look at it, we could do 199. What's 1 minus 4? That's a negative. Is that here? That's not a question do I have, right? So we don't do negatives. What we do is we do positives, but we do the inverse. So, sorry, oh, got it. So 1, 2, 3, 4. This is how we count to 4. When we count to 4, we have 5. So we have 5, sorry, had a brain fart. 5, 6. So we put them together. This is 6. And then this is 7. 5, 6, 7. So does that make sense? This is 2. Just as though I see it, there's only 2 beads. And then this is 3 and 4. After 4, this is 5. That's it. All the top bead is a value of 5 no matter what. So we have 5, 5, 5, 5, 5. These are all 5s. But now if I clear it, now my abacus is zeroed. Yeah, great. Oh, okay, great. Whew. I was thinking you knew how to read the abacus. I was going to do more division. But no, let's talk about adding. Because what we need to do, I don't know if Jose left. Jose, are you still here? So when we are counting, we have our place values. So with our place values, we have our ones, our tens, our hundreds, our thousands, and our 10,000. So after we figure this out, it's the same thing. So this is 9, and then this is 99, just like our tens. And then this is 999. If I do it again, this is 9,999. And then this is 99,999. All 9s. But it all depends on the place value, just like how we write. Now, the question is why am I here? The reason why is because I chose this indicator, this dot indicator, to be my ones place. Because this is my ones, so I have my ones, my tens, my hundreds, my thousands, my 10,000. Anything after the ones would be my tenths. It's just like your decimal. It's just like the decimal. Notice the decimal sits between the ones and the tenths. So I have my decimal right here. So just like as we have money, right? How much is a Frosty. I think a Frosty is like $7, right? $7.38. So $7.38. So now we have money. So we can use these two columns for money. I know that's one of the big things for the young kids to start talking about money. But we don't have to. I mean, if anything, you could use up here. And then it just depends. And then abacus is the gateway to complex math. It's also interesting because there's a lot of algebra in abacus. When we start isolating the variables, when we start working with formulas, that's when we start talking about adding and subtracting. Anybody have any questions? Hey, Ethan, welcome back. And hello, Michelle. I only see 3 people on my list. But I don't know if Jose left. And I think Melinda's in the house. Hey, Amma, you're back. Okay, so we're going to continue on. Now, important tip that the beads touching the dot is not a decimal. That's correct. It's the one right after the dot. Correct. I'm a math teacher. This is incredibly fascinating as someone who didn't learn it this way. That's very interesting. Emlyn. Hey, I just got here. Can you do a quick review on how it works? Oh, fantastic. Thank you for the comment. Yes, that will be easy. Easy. Okay. So what's going to happen is we do 1, 2, 3, 4. When we look at our abacus, right? The abacus is what helps us count. We can also do adding, subtraction, multiplication, division. Manda, I would start, if your kids are 3, 4, and 5, we can start then. I was trying to target children that are 3, 4, and 5. 7, 8, 9 is good too if they're open to learning something different. I think 9's kind of pushing it. If they're open to it, then that's great. 10, 11, 12, they already have attitude coming in, so I think it'd be difficult to show them unless they already have difficulty. Then you might want to show them like an intervention, like a math intervention. I would totally recommend using this as a math intervention. Mine just turned 4. Oh, yeah. So yours just turned 4. Oh, thank you so much for the lightning. Wow, that's a lot of lightning. I have, can people start at 14 plus? You know what? I learned the abacus when I was 30. It is possible. We will just never be as fast as the young kids. So, Mandy, thank you so much. Suave Lanzo. I have this one book. This is available on Amazon, and that's my name. And what I did was I have it where I have these exercises where it's all abacus specific. I would recommend at any age. Thank you so much, Lonzo. Oh my God, so generous. So I have it where they recognize the numbers, they recognize what the beads are, and they recognize like how to trace. So this one was more about bead recognition and so forth. And then here I have it where they talk about, how to count backwards, how to count forwards, and so forth. And then right afterwards, after the relationship of the numbers, we can start talking about the addition, the add-ins. And so that's what we should talk about is the add-ins. So if you notice with the add-ins, abacus focuses on the add-ins and not the result. We marry the process and divorce the result. I don't know if anybody's heard that, but that's like really big on TikTok. marry the process and divorce the result. Oh, thank you so much, Lonzo. I do appreciate it. Wow, 330. Thank you so much. Lonzo's still gifting. That's fantastic. Thank you so much. I do appreciate it. So going back to here, marry the process, right? Marry the process. And why? Because we don't want to focus in. Yeah, right? We don't want to focus on the result. What we want to focus is we want to focus in on the add-in. So what that means is if I look at 2, because my add-in is 2, I want to have 6. I have 6. And then here, I want to know what 2 looks like. So as I do it, I only want to touch these 2 beads and I'm going to move it up. And what we just did is we added 2. Does that make sense? But it gets strange. I feel like that's double meaning. It is double meaning. It's one of those things that it's really popular in TikTok. TikTok is marry the process, which means just keep posting and putting in your content and don't worry about the views. So there's a lot of quotes that I pick up that's really interesting and it makes a lot of sense. Just like how I say we want to we want to enjoy the journey and not how is that six? This is six. So Emmeline, this is 6. So we have 5, 6. Every top bead is a value of 5. Because we have the value of 5 and then we have 1, this is 6. When we squish them together, this is 6. And then this is 7 and then 8. What we did is we added 2. And when we added 2, now we have 8. 5, 6, 7, 8. And that's how we did it. Enjoy the journey and not worry about the destination. Yes, exactly. Or the goal, right? Like everybody's goal is one to be happy, but how to get there is another problem, right? Is another situation. It's the same thing with Abacus. Abacus kind of mimics life. And that was the thing. Yes, exactly. After the fact, Alex. That's what I was trying to get to. But then I got confused. I got confused. Emmeline, I got confused. Does that make sense, Emmeline? Does that make... Okay, so what we're going to do is we remember that the top bead has always the value of 5. So even if I did this would be 58, right? And then this would be 68. And then, okay, so then we'll do this. Notice we don't, in Abacus, we don't memorize our doubles. We don't need to memorize our doubles because we have formulas that we need to memorize. We don't need to clutter our brain with doubles. Because doubles only work one way. You don't do a negative doubles. Negative doubles. Exactly. The top bead will always be a value of 5 no matter what. 1, 5, 5, 5, 5, 5. So there's this one person asked, well, what if you put 2 top beads in is that 10? No, that's not 10. Why? Because this is 5 and this is 5. So this is actually 55. If you want 10, we just do that. That's 10. That's it. 10. 1. 1, 10. Because what? 1 and 0. Because I said that this is my ones place, if you notice I have a dot here, because this is my ones place, I called that this is my ones. Like Pokemon. I choose this dot to be my ones. So, yes, so that would be 55. But now we have 65, right? Because I kept the 1. So we have to pay attention, what was it? Pay attention to detail. Because some people forget that there's a 5. And when we add it, right, this is 65.55. Does that make sense? All right. Whew. I need to learn this. We're learning. We're learning. Oh, Manda. So are you understanding, Manda? Okay. So, Adrian. Okay, I'm thinking it's Adrian. I hope it's Adrian. We're going to count. 1, 2, 3, 4, and then 5. All the top beads has a value of 5. As we see 5, into you, Kez. Thank you so much for sharing the live. Okay, 5, 6. How do I know? Anytime the beads are touching the horizontal bar, we're counting it. My mind's sometimes too fast that I forget the decimal or the 5. Yeah. Sometimes I talk too fast and I think I say the wrong numbers. So when the beads are touching the horizontal bar, this is the horizontal bar that's going to help us track. Is it possible to use negative values? Not really, Barlos. I think when we do it, we do a takeaway, but for the most part, we don't do negative. We don't do it. You would have to keep it in your mind, and then it get confusing really quick. So wait, the top bead. How can you do? So how would you show 45? 45. Come on, Shelby, give me something harder. So this is 45. How do I know? Because it's 4. 1, 2, 3, 4. This is 40. Just like in our tens place. So if there has my tens, this is my tens column. This is my ones column. So 45 is 4 and a 5. Right? So then if I have 745. Oh, sorry, I just got here. And you were showing 5s. Yeah, no problem. No problem. I was just kidding. A harder question would be nice. No, yeah. No, that's great. I'm happy that you made comments because I don't know where people come in and I don't know where we're all sitting. So, Bree says, how would I know the difference between 45? Okay, yeah. So here, 45, that's a really good question. Here's 40, right? 45 looks like this. 43 would look like that. So it's this top bead that gets counted. When we add it, if I add it now, I have 43. When I add it now, this would be 48. I wasn't exposed to any math beyond hi-ho cheerio until kindergarten. I actually don't know what that is. Hi ho, cheerio until kindergarten. I don't know what that is. Bree, does that make sense? So when we look at it, this is 43. Okay, let me this is my ones. So after my ones, what year of preschool would you introduce this? What year? I would say probably ages 3, 4, and 5. Oh, okay, great. Game A. I don't know what that is. I would say I would start them at 3. I have a book that I was trying to get them to be 3, 4, and 5. I do have other worksheets that do a lot more cutting and pasting and more game-like. This is turned into a book. I do have a couple of other books that are a little bit more interactive. And then after they know how to read the beads and after they understand the relationship of the numbers, like how to count forward, how to count backwards, what's bigger, what's less than, then we start going into adding and subtracting. And this is like simple stuff. Hi ho is a game. Oh, it is? So the top blue bead is always going to be 5. Yes, clown. I think it's a clown. So for example, 17 would be one green one. And then in the tens place, yes. And then it would be one blue, one green, and one yellow. Correct. Because all the bottom beads has a value of 1. So when we're looking at this is 1 and this is 7. If I remove the top bead, if I remove the blue bead, this would be 12. So the kids will start seeing that they can decompose. As they see that they can show, add 5 and 2, I get 7. If you do 5 and 3, you get 8. 18. You mentioned variables using algebra. How would you do that then? Oh, so what's going to happen is if we understand how to do simple adding and subtracting, if we're understanding how to read the abacus, we can start going into addition and subtraction. Yes. Are we okay with reading? Are we okay with that? Hey, Stephanie. Shelby, are we okay? So again, when we start talking about before I continue on with addition, the colors don't mean anything. That's correct, Ethan. That is correct. So there's another abacus. I like the colors, right? But there's this one, and it works exactly the same. I mean, but if you notice, Shelby was able to explain what it means. Same thing though. 17 is one brown bead, one brown top bead, and 2 lower brown beads. So this would be 17, if that makes sense. Okay, good. So what we're going to do is we're going to continue on to add. When we're adding, and this is already the beginning parts, so you'll notice, yes. So you'll notice that when I have 12 and I add 5, there's enough beads to add the 5. This is a critical question. Is there enough beads? When we don't have enough beads, like when do we never have enough beads? When we have it is when we do 3 and we want to add the 4. Now, why do I want to add a 4? Well, that's just the question. I want to add 4. But there's not enough beads to add the 4. Well, what are we going to do? What we're going to do is now we understand. Here's a question. Who remembers how to make a 5 with 2 digits? I'll give you a first one. 4 plus 1 is equal to 5. What's another way to add a 5? What's another way to make a 5? How do we make a 5? Yes, thank you, Ethan. So we have 3 plus 2 is equal to 5. And then the other way, how do you know where the tens and the ones placed aside? Oh, that's where my dots happen. So my dot is my indicator of my ones place. So my ones, my tens, my hundreds, my thousands, my 10,000. You could use this as your ones. On the bigger abacus, it's the same concept. I like to use the middle because this is 13 columns. I like to use the middle. However, if you want a bigger number, you can start from here, or you can even start from here, which is the edge of the thing. So it'd be 13. So this is ones, thousands, millions, billions, and trillions. So it doesn't matter where the home is. Your home can be anywhere. Your ones can be anywhere. You just need to choose one indicator, one dot, one label. So this is what we're doing, and we were talking about, so do you just need to choose what you need at the time? That is correct. You just need to choose whatever you want. So like for me right now, because this is a smaller abacus, I usually go here because the questions that we have will have more whole numbers than we have decimal numbers. I love the Sorbonne. Hey, Kelly. Oh my God, you got 3? Did you get the colorful ones or did you get like the 13 column ones? I was trying to find. Barlos was talking about journey destination. Somebody was talking about algebra. I completely forgot who it was, but we're going to start getting into it. I'm planning to do more abacus. Yes. Okay. So what we're going to do, the question is 3. This is a simple question, I know, but it's fundamental. Why? Because now 21. Oh yeah, 21. That's a good one. What we're going to do is we're going to look at this 4. This 4 is our variable. Now, this is where we get a little bit of algebra. The variable is this. We're going to isolate our variable and we're going to move it to the other side. We're going to move our 1s to the other side because we want to isolate the variable. When we isolate the variable, I'm going to rewrite it. 4, I'm going to say plus the 4 is equal to plus the 5 minus the 1. So what does that mean? This is the formula that I need to memorize, and this is what we do substitution. Why? Because if you notice, when I add the 3, I don't have enough. When I don't have enough, I need to figure out how to utilize, supercharge my 5. Make sure I make my numbers work for me because I want my numbers to work and to not be such lazy bums, right? This is a concept that we know. Now we're going to get them to work. So what's going to happen is I want to add 4. To add the 4, I'm going to add the 5 and I take away the 1. So now my answer is 7. Does that make sense? So we don't memorize our doubles. What we memorize is the formula. When we memorize the formula, then we can utilize it anywhere. So that was 1. Let's do another one. Let's do 2, right? 2 plus 4. Again, we have 2 plus 4. Well, we can just learn our doubles and plus 2. You could. Or you can take a look at this. We have 2. And then we need to add 4. We've already isolated the number. We've already isolated it here. So all we have to do is substitute 4 with this. This is plus the 5, take away the 1. So my answer is 6. Does that make sense? So what we just did is the beginning parts of algebra. And then it gets more complex because we start doing two-step equations. But that's the first thing. Actually, that's... Oh, wait, that's actually so fun. What a cool way to think about it. Yeah. And so when you learn adding, we have to subtract, right? We need to balance we need to balance, right? So when we know to subtract, we just take away from the horizontal bar. That is subtract. Unfortunately, that did not make sense. That's okay, Grant. We'll continue. We'll continue and we will. So how would you calculate a bigger number? We could do that. Is this applicable to binary, Dominic? I don't know. Going binary is above my pay grade. All right. So, Emmeline, let's do it. We're okay. Wow. It's starting to make a little sense, right? Yeah. Good. Cool. Thanks. Anyways, sorry, yeah. I don't speak binary. All right. 3, 6, 5, 7, 6, 5. Now, one thing is we need to understand is there might be some two-step equations. If we're okay with that, we can do it. We're going to start with this one. So the first thing we're going to do is instead of do ones, tens, hundreds, what we're going to do is we're going to go left to right. We're going to go from 765. So the first thing we're going to do is we're going to add our digits to the abacus. We'll do 3, 6, and then 5. Okay, I got to go a little slow because, so basically she substituted the 4 with the 5. Yes, 3 is, yes, exactly. That's what it was. That's what it is. Yes, Josh, but well done. And that's exactly what I did. Because and then if you notice, That's a little bit of substitution. We're going to get more complicated. This is actually complicated. This is going to be a little bit more. Why? Because now we're going to talk about how to add how to make a 10. To make a 10, in this one, we want to add 7. There's not enough beads to add the 7 here. Does that make sense? If there's not enough beads to add the 7, what are we going to do? We know 7 plus 3 is equal to 10. Now we need to isolate the variable. We know how to do it the first time. We're going to do it the second time. 7 is equal to plus the 10 minus the 3. Why are we going to do that? Because we don't have enough beads to add 7. We need to utilize our 10 to make our 10 to make our 10 useful. We know if we add the 10, it's too much. So we have to take away the 3. So that's adding 7. So we're done with 7. Now we need to add the 6. Whoa, we need to add the 6. The 6 is going to be a little much. Why? Because now we're going to start talking about a two-step equation. We will continue with 6 plus 4 is equal to 10. Notice, I'm going to isolate my variable. I want to isolate my variable to make it a 6. So what I'm going to do is 6 is equal to plus the 10 minus the 4. I'm going to plus the 10 because this is the 6, right? I'm going to add it to the 6 to the 10s. Add the 10, take away the 4. There's not enough beads to take away the 4. We know a concept, right? We know a concept how to utilize the 5. But this time it's minus the 4. To minus the 4, looking at it, it's minus 4 minus 1 equals to minus 5. If you keep them all the same, then we can isolate this variable. Notice this 4 and this 4 are the same. So what we're going to do is we're going to minus the 4 is equal to minus the 5 plus the 1. I say minus the 5 to remind us that we're going to take away the 5. So we're going to take away the 5 and we plus the 1. When we take away the 5 and plus the 1, we're done. Now we need to add the 5. So we're done with this and we're going to add our 5. So you always move into the 5 intervals with 10 if it's greater than 5. Yes. Yes. And you always look at the 5 if you can use it or not. So numbers like 4, 3, 2, 1, before you go to the 10, make sure you can use the 5 first. 5 will always be the next step. For these numbers only, for these add-ins, you need to see if you can use a 5. So I'm going to add the 5. We know how to add a 5. How do we add a 5? 5 plus 5 is equal to 10. We need to isolate the variable. So 5 is equal to 10 minus 5. So what am I going to do? I'm going to add the 10. And I take away the 5. The Sorbonne has helped me with visualizing numbers. I have fun calculating my groceries in my head now. Oh, fantastic. What is my answer? That's fantastic, Caleb. Thank you, Melinda. 1,130. Yes. 1,130. But see, these... I had a little saying too. It was another saying that I found out that was really good. It was build the necessary foundation. So what we're doing here is this is foundational information. This is what we have to memorize. This is fantastic. It's definitely different to think about it from left to right, but it makes more sense, right? Because we don't say 567, we say 765. And I thought that was really interesting. We do the same thing with multiplication and we do the same thing with division. But this is just the beginning parts. So if you want to do more numbers, we can add more this. But is everybody tracking what this is? Like the two-step equations? Does this make sense? I'm hoping it's okay. Because what it is all we did is we just learned how to make a 10 and how to make a 5. And we just figure out how to mash them together, like Play-Doh or yarn, and how we make we make a we make a scarf, or we could make a hat, or we can make a sweater. Yeah. Okay, good. Okay, good. Yes. Yes, I understand now. But this way it takes it long. Why would anyone use it? It takes long because we need to understand it first. So, Emmeline, when we understand it, I mean, I can go pretty fast. And if I had bigger numbers, I wouldn't have to do this because I would know how to do it. You know what I mean? But it's different because I'm trying to explain it. But then again, I'm in 7th grade math teacher, so I spend so much of my day with this mental space. Yeah. And that was the thing, like, that's the interesting thing. It is, but it's different than before. It is, but it was different than before. Yeah. So, Emmeline, I mean, it's slower because I just explained everything. But if I just did it, it'd be a lot faster. But I'm explaining it, so that's why it would take longer, if that makes sense. It's just like in school right now, we're building out pictures. So the pictures are, let's do 300. We have 300, 1, 2, 3, and then we have 6, 1, 2, 3, 4, 5, 6, and then 5, 1, 2, 3, 4, 5. And then we have 7. We got to do 7. 1, 2, 3, 4, 5, 6, 7. It's about quantity. So this is good to show quantity. So we have 6. 1, 2, 3, 4, 5, 6. And then we do 5. 1, 2, 3, 4, 5. We could do this. I mean, this is what they're doing in math right now because they want to show quantity. But in Abacus, we show place value as well. So then we combine them all. 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10. Right? This is 1,000. And then they do it again. 10 plus 10. 5 plus 5 is 10. And then this is 2. So, but yeah, like they have to know that this is 100. And then we have 2 here, but then this is 5 plus 5. Then that's also 3 because it's 1, 2, 3. So there's 3 right there. So, what's your favorite number? What's my favorite number? I think 4 because it's very versatile and you can do a lot more questions with 4. You can do a lot more questions to add 4, but you can't do two, you do the same amount when you subtract 4. And then and then even 9. But maybe 1 is good too because I like 1 as well. 1 gets kind of cool because 1, there's many ways of adding 1. Adding 1 is like doing a carrying over and borrowing. So that's the interesting. Maybe it was 1. Maybe 1. I like 1 because you could do so much with 1. Anyways, so does that make sense? Okay. But I mean, this is what they're doing in new math. Whereas in Abacus, this is what we do. Those are great. Yeah. So this would be like Abacus, but because I had to explain it. So a standard deviation. So a standard deviation, I don't know what that is. That's above my pay grade. If that's algebra, I know somebody algebra that can help you. But we don't do standard deviations. What we do is arithmetic. We do adding, subtraction, multiplication, and division. Okay, so Kira is here, and Shelby and Krista. Any questions? Make sense? Any other questions? I mean, that's doing this problem, that's the gist of it. As long as you understand as long as you understand the fundamentals, then you go further into standard deviation is plus or minus the 1. No, we don't do standard deviation. We do it's a specific add-in or the subtracted. So if we do a -1, there has to be a number to go with it. Right? So if I want to take away 9, if I want to take away 1 from the 9, all I got to do is take away the 1. So it's not a standard deviation. I don't think that's the proper, I don't think this would do it. Isn't that statistics? Yeah, I think so. I think that's statistics. I mean, I don't know statistics, so I can't teach it. Sorry. Okay. Oh, okay. Yeah, sorry. That's above my pay grade. I only know arithmetic. I only know elementary math. All right. So again, we're talking about this part. As long as you understand how to make a 5 and how to, meaning I'm not good at it. Oh, what are the blue ones? Oh, thank you. Sorry to interrupt. No, you're fine. Standard of deviation is not always one. Okay, okay. Aves. We're gonna count 1, 2, 3, 4. So what we're gonna do is understand that anytime the beads are touching the horizontal bar, when it's in contact with the horizontal bar, we're gonna count it. So this is 4. Then the top bead will always be 5 no matter what. So we have 5, 6, 7, 8, 9. Notice this is 9. How do I figure that out? Because the top bead is touching the horizontal bar. When the top bead touches the horizontal bar, this is 5. So we have 5, 6, 7, 8, 9. After this, we know what 10 is because we've seen it before, just in a different column. This is 10, just like how this is 1. Hey, Sai. Thank you so much for liking my life. So this is 1, but notice this is also 1. The difference is the column. So when I look at my columns, I have my 1s, my 10s, my 100s, my 1000s, and my 10,000. So the columns represent place values on the abacus. How's it going, Sai? We were just doing some division, and then we went back to addition and subtraction, and then now we're going back to counting. So, Aves, does that make sense? We are talking about 11. How do I know? 1 and 1 makes 11. So this is 11, and then this is 21. How do I know? Because it's 2 in the 10s and then 1 in the 1s. When we continue to count, we could do 26, and then 36, and then 536. I don't know if Aves is still around. So, Aves makes so much sense. With the paper, with the little paper. Yes, I made the little paper. Yes, because people were asking me, and I'm like, I'm tired of writing. Okay, so 639 sin when we were talking. This is how you do 6. This is how you do 3, and this is how you do 9. That's it. I love long division and multiplication. You do. It's funny. You guys are so funny. Okay. So when we talk about it, we have, so why are we here? The reason why is because there's an indicator. This indicator, this dot right here on the horizontal bar, this is what I deemed as my ones place. I crouched down because I feel like I need to be close, but my eyes are old, so I gotta go far. Anyways, all right. This is my ones place. Why? Because my indicator, my dot right here, this dot right here on my horizontal bar will tell me that this is my ones place. You could choose this one. It doesn't really matter. It actually doesn't matter which one you choose as long as you choose one, right? Just like in Pokemon, just choose one. This one is a 13 column abacus, and the 13 column abacus works exactly the same as a colorful one. The colors have no meaning. It just means the only difference is if it's a top bead, these are all top beads, and these are all the bottom beads. There's the bottom bead. So when I show you 6, it looks exactly the same. When we start looking at it, this is 7. It works exactly the same. It's just one's colorful and one's not. And I just think that sometimes with color it makes it fun and easier to read, because I think the brown in the video, right, is a little harder to see. So I think that's why, and it's easier to explain what the numbers are. So the colorful is easier to see and quickly. Yeah. That's why I use this one most of the time, unless we get to bigger numbers. When you get to bigger numbers, then we have to use more. I have to change it over to a larger column because of the digits. That's all it is. Thank you for the follow, Wolf Girl Running. Nice. Okay. So did that make sense? So we have this is our ones. The dot. This is my decimal. This decimal right here. Can you do? Yeah, we can do it. Hey, Sarah. Are we ready for two-step equations? So we could do it. The issue is whether or not they can understand this part. Can you show 37? Okay, so let me write down 371 minus 458. Okay, so the question is 37. Okay, 37 plus 4. Yeah. So we know, Alex, after the fact, we're going to do 37. 7. The first thing we need to do is figure out, do we have enough beads to add the 7? No, we don't have enough beads. The next question is can we add the 5? No, we can't add the 5. Now what do we do? Well, how do we make a 10? How do you use a 4 to make a 10? 6 plus 4 is equal to 10. When we isolate the 4, when we isolate this variable, we're going to do 4 is equal to 10 minus 6. This is the formula that we need to remember. This is the formula that we need to know. So we're going to plus the 10, because what are we doing? We're adding the 4 here. We're going to plus the 10, and then all we got to do is take away the 6. So my answer is 41. Did that make sense? But this is a formula. This is a foundational element that we need to memorize. Yeah. Okay, are we ready for 731 take away 458? Let's do it. Okay. Wait! Hey, Beast Boy. It's an abacus. We're going to count. This is how we read the abacus. So we'll read the abacus first. 1, 2, 3, 4. Thank you for the comment. I hope this helps. 4. Why? Because the horizontal bar is what counts the abacus, right? Counts the beads. We have 4. And then we have 5. All the top bead will be value of 5 no matter what. So now we can count above 5. We have 5, 6, 7, 8, and then 9. Now what's 10? Well, you've seen 1. Remember what 1 looks like. This is what 1 looks like. But we're going to go to the next column, to 10, because it's a 1 and a 0. When we look at our abacus, we have place values. This is the 1s. This is the 10s. This is the 100s, the 1000s, and the 10,000. Does that make sense, Beast Boy? Let me know if you have any more questions. I'm going to continue on. I don't even know if you're still here. I keep saying it. Hey, Shu, B, and Angel, welcome. Have any preschools incorporated this into their curriculum? No. There's like less than 1%, less than 1% knows what an abacus is. Yeah. The kids that I see in my school, the kids that I see in my learning center, they're usually about 5. I noticed that we're missing some of the kids that are in preschool. So now I have daydreams. I know somebody in France. She picked up my books, and you sold me. Oh my God. Thank you, Alyssa. Let me know if you have any questions. I have more worksheets. I have so many worksheets. I have some that are cutting, and I have some that are puzzles. But I'm excited for you. I'm excited for your child. Yeah, and I hope that the worksheets are good. Okay, so the common in India, and it's very common in India. It's like as many Starbucks as there is in America. There's a Abacus Learning Center. And you know what? It's really popular in Africa. I have a few African teachers, Abacus teachers following me. Kids in India do Abacus with their fingers so fast. Yeah, they do a lot of this. Some of them gets really like dramatic and they're like this. Okay, sorry. We're going to continue. We're going to continue. So the question is 731 minus 45.8. So in Abacus, we don't call it regrouping. What we're going to be doing... Oh, good. You're still here, Beast Boy. I wasn't sure. All right. The first thing we're going to do, because I think it was... question. I need to find my... Where are you? Okay, there we are. Sarah. Okay, Sarah. So what we're going to do is we're going to put in 735. 731. The next thing we're going to do is we're going to take away the 4. To take away the 4, we need to understand how to minus the 5. So what we're going to do, minus the 4 is equal to minus the 5 plus the 1. Hey, Gabby, welcome back. So we're going to minus the 5 and then plus the 1. Now what are we going to do? We're going to do minus the 5. This one right here, minus the 5. Minus the 5 is minus the 10 plus the 5. Can I take away the 5? I'm sorry, can I take away the 10? Yes. So I minus the 10 and I add the 5. Now what do? I have to do 8. Minus the 8 is equal to minus the 10 plus the 2. So what's going to happen? I have to take away the 10. So I'm going to take away the 10 because I'm going to add 8. I'm going to take away the 8 here. When I take away the 8, right here, I have to minus the 10 and then add the 2. So my answer is 273. Yeah. Yeah, you know, it's great. I'm sorry, what grades were you teaching? If you can remind me, Sarah, because I know you were talking about it. There was regrouping, but see, we don't talk about regrouping in Abacus. What we do is we just minus the 10. But there's some of them gets really complicated. And that's when you get into two-step equations, because sometimes you have to understand how to add the 2. I love this. Oh yeah, hey Peachy, welcome. Oh, okay. Okay. You could the first thing to do would get them all to understand how to read the abacus, and then the next one would be to go to understanding how to simply add. So if I have 3, 1, 2, 3, and I add 5, so that's just moving the beads. And then after learning how to move the beads, then you go into adding how to make a 5. I love to learn. Hey, Peachy. So what we're doing is we're going to count because we need to understand how to read the abacus, Peachy. So the first thing we're going to do is going to do 1, 2, 3, 4. Oh, and Sarah, so making a 5 is 4 plus 1 is equal to 5, right? Or 2 plus 3 is equal to 5. Peachy, we're back to you. After 4, because the beads are touching the horizontal bar, we're going to go to 5. All the top bead has a value of 5. First time joining, I understand it now. You're amazing for doing this. Oh, thank you, Victor. Yeah, thank you. Thank you for joining and commenting. There's not too many people that comment, so I'm like, I don't even know if anybody's here. Okay, so 5. So the top bead will always be 5. Does that make sense, Peachy? Are you a horizontal bar? Are you tracking me? The horizontal bar tracks all the beads, right? So the horizontal bar is what makes everything counted. When you notice none of these beads are touching the horizontal bar, thank you for being so patient and teaching. Yeah, not a problem. Not a problem. I'm happy that there's comments, so then it'll be easy to understand. Girl, there aren't any abacuses in your TikTok shop. You know, I was trying to figure out how to get this onto the TikTok shop, but I have to send over a kid toy document, and I'm like, I don't even know how to do that. Oh man, but I do sell it. I do sell the abacus on my website, but I can't figure out how to get it into TikTok shop. I'm still trying to figure that out. Yeah, I just started. Okay, sorry, Peachy. So all the top bead is a value of 5. So when we count, we have 6. How do I know? Because we have 5 and we have 6. 5 and 1 is equal to 6. I'll have a replay. Oh, thank you, Krista. Yeah, the link's in my bio. So 5, 6, and then 7. 5, 6, 7. So this is 7. And then we have 8. Notice I have 5 plus 3 is 8. And then 5 plus 4 is 9. Does that make sense, Peachy? I use the 10 bead and then 1 bead and when I was 10. Yeah, I get it. Okay, good. So, Alberto, we have 10. This is what 10 looks like. How do I know? Well, if this is 1, then this is 10. Why? Because we have our place values. So with our place values, we have ones, tens, hundreds, thousands, and 10,000s. So we have to make sure to understand the place values. We can do this one. This is 60. Then this is 70. And then this is 80. Same thing. This is 90. 987. Notice the difference? Alberto, the 10 bead one. Do you still have the 10 bead one, Alberto? You can make it, you can modify and change it into a soroban, but it just takes some modification. There's a few people that, oh yeah, there's a few people that actually have a 10 bead one. Not anymore. Aw, sad face. But yeah, this is called a soroban, which is a Japanese abacus. And the Japanese abacus does a one top bead and 4 bottom beads. So this one is how, when we count it, we have 5, 6, 7. All the top bead has a value of 5. May you do a math problem with it, please? Yeah, you want multiplication? Multiplication! Yeah, we can do multiplication, not a problem. Are we okay, Peachy? Does that make sense? Do I need to explain more about how to read it? Before I go into multiplication for Eric. And then Alberto, does that make sense on how to read? Okay, cool. Are we okay, Alberto? When we read it, we do 1, 2, 3, 4, and then 5. So all the top beats has a value of 5, no matter what. So this is all counted. This is not, this, okay, good. This is not 10. This is 55. That's 10. All right. Multiplication. All right. Easy to do multiplication. The biggest thing about abacus and multiplication is making sure that everybody knows how to do their multiplication fact. I'm here for multiplication. Yes, I'm here for abacus. So let's do something easy. Let's do something easy, right? What's easy? Well, the first thing we're going to do is we're going to do 42 times that by 2. So again, abacus, we don't know, we need to know the fundamental math fact. We need to know that our 2 times table. So this is our 2 times table, right? What we're going to do, because it's multiplication, we need to figure out where are we going to put our answer. Why? Because when we do it, we go from left to right. We don't go so in old math, we did this, right? We did the ones first and then the tens. We don't do it this way. We're counting the digits. Yes, we count the digits from left to right as we read. Yep. Thank you, guys. Thank you, Sai. Thank you, Melinda. So when we count it, we go 1, 2, 3. We know we're going to be in the hundreds place. What does that mean? 1, 2, 3. This is my hundreds place in my abacus. I counted 3 digits. Right? 2 digits plus 1 digit is equal to 3, just to get an idea. Hey, L, you're going to have to wait a little bit. Let me do some multiplication, and we'll come back to do some counting if you want to wait a little bit. So the first thing we're going to do is not 2 times 2. What we're going to do is we're going to do 2 times 4. So we go from left to right, just as we read. We don't say, 40. We say 42. So just as we read it is how we're going to multiply it. So the question is 2 times 4 is equal to 8. 8 is a single digit. So my finger is here. Because 8 is a single digit, I'm going to go back 1 column. I'm going to add the 8. Then my next one is 2 times 2 is equal to 4. I do 2, right? 2 times 2 is equal to 4. 4 again is a single digit. I go back 1 column and I add my 4. So my answer is, what's my answer? What's my answer? Easy, right? But notice, however, 84. Yes, Sai. But notice, thank you, Alex. Yes. So, but notice, I don't say 40 times 2. We don't need to say that. Thank you, Josie and Melinda. Okay, we want to make sure I don't need to say 40 times 2. All I need to do is say 4 times 2, because 4 times 2 is going to tell me my manageable chunk. So, L, you're still here? I hope you're still here. We're going to count. We're going to count 1, 2, 3, 4. All the lower beads. Hey, Naomi. Awesome, Ricardo. Oh, cool. Hey, welcome. Welcome. I'm so happy you guys are here. Comment if you don't have any, if you have questions. L, I hope you're still here. We're going to count 1, 2, 3, 4. Anytime oh, good, you're still here. So anytime the beads are touching the horizontal bar, this horizontal bar is what's counted. We use the horizontal bar to track our numbers. So if you're tracking, this is going to be 5. The top bead will always be a value of 5. So we have 5 and then we have 6. How do I know? Because the top bead is 5 and the bottom bead is 1. So we have 6. Okay, we'll do that. Okay, so that's easy, Sai. Okay, so we have 5 and 6. 5, 6, and then we have 7. 5, 6, 7, and then 8. 5 plus 3 is 8, and then 9. 5 plus 4 is 9. So this is 9. Thank you for the follow, Naomi. This is 9. Notice that every column you can do 9. So people can understand the answer being 3-digit. Ah, you're so smart. That's a good one. Okay. Yeah, you're right. You're right. We'll do that. We'll do that. So this is 9. But this is not 9. This is 90. When we look at it, okay, that makes sense. I should make it more double digit. Okay, sorry. So when we look at it, we have our ones, our tens, our hundreds, our thousands, and our 10,000s. Each column is a place value. Okay, I don't know if L is still here. Shubi, do you have any questions? Okay. So we have the one question, which is 50 times that by 2. So again, we're going to count our digits. We're going to count our digits. 1, 2, 3. When we count our digits, thank you for the follow, Caleb. When we count our digits, it's 3, right? 2 plus 1 is equal to 3. So when we look at it, 1, 2, 3. Make sense? Hey, Mary, thank you for the share. And then what we do is we go from the outside first. We go left first. We got to go left to go right, just like cars, where Lightning McQueen needed to go left to go right when Doc Hudson said, you got to go left to go right. I'm sorry. Okay, so the question is 2 times 5 is equal to 10. Yeah, I get a little corny. My kids don't like it. So I'm going to add 10. Add 1, add 0, and then 0. So my answer is 100. And that's it. We could do another one. Let me see if I can find a better one. Well, better than mine. This was a good one. Sai gave me a good one. Let me do I think that's what it is. I forget. Okay. How about this one? Maybe not that one. Maybe we do... Okay, let's do this. 29. Okay, let's do another one. Nice. Okay, Josie after 5. Okay, we'll do... Oh, you know what? Thank you. 67 times that by 4. Okay, and then we'll do the other one. 80. We'll do the other one. 41 times that by 9. Okay, so I got that down. All right. So the first thing we're going to do again is we're going to change markers, actually, and we're going to count our digits. You're shifting into midnight mathing mode. Yeah, it's going to go to do division pretty soon. Okay, we're going to count our digits. How does the abacus with 2 beads differ? Okay, Victor. Okay, you know what? Let's take a little break on this, and let's talk about the 2-digit one. Okay. Hey, Robert, welcome back. So Victor, the Chinese one is a 2 bead on top. They're different, and the Chinese one is a little bit redundant. There's a lot of exchanges that happen. There's a lot of extra steps. What that means is when we count 1, 2, 3, 4, 5, because we have 5 here, we know that we need to exchange it. So 5 is the same thing as that. But on the Japanese abacus, this will always be 5 and 5, always, no matter what. Does that make sense? So here, this can be 5, or this can be 5. Now there's two ways to do 5, but in Chinese you have to in Chinese the method is that they have to exchange it. So after 5 is 6. Same thing. 6, 7, 8, 9. 6, 7, 8, 9. Not a problem. But now we have 10. And I was like, you know what? I'm at the door. This doesn't make any sense. Why? Because we just messed up the place value. Because now this is 10. I was like, why is this 10? This is not 10. It can't be 10. Because 10 is this. Tens, then ones. This is not 10, but it is. Because then what happens? Well, we exchange this 5 to the 5 on top. Every top beat is a value of 5. So we have 5 and 5. But because we have two 5s, we have to exchange it for this one, which is 10. Now it makes sense because now we're using the columns like they're supposed to. So we have 10. But notice, if I did this, this is 10. Or this is 10. Or this is 10. So the problem is in Chinese abacus, you have to do an exchange. This is not 22. This is actually 110. Because if this is a 10, but it's in the wrong place value, right? The place value should be here. So there an exchange has to happen. So this is a 10. I'm sorry, this is 100. So 110. But see, there's a gap here, and that doesn't make sense. So you have to exchange this 10 for this 10. Now it makes sense. Yeah, right? So now it makes sense. There's a lot of exchanges that that needs to happen before you get to the right place value. So Japanese people, like they all do, they make it more efficient. And so that's why we have 10 over here. Oh, I see why it's a bit redundant. Yeah, exactly. So there's a lot of exchanges when we do 5 and then we do 5. And then if we did 10, we got to do, if this is 10, then we got to do 10 here. So you'll see a lot of moving of the beads, but know that what they're doing is that they're also exchanging as well. It's not necessarily using formulas. I don't know if they use formulas. They might. So if I did 2 plus 8, 5, 6, 7, 8. Maybe they don't even need to use the formulas, right? So if I did 4 plus 4. No, they would have to do the formulas. Because plus the 4, if I want to add another 4, 5, 5. Yeah, they would still have to do the formulas. Yeah. The Japanese version is more efficient. Yeah, it's more efficient actually. But yeah, in the Chinese abacus, you still need to do division. You still need to do the formula. So like if I had 4 and I want to add another 4, I still need to plus the 5 minus the 1. So it's still easy. Maybe the Chinese one is useful for working for other bases. No, the Chinese one was made before the Japanese one. So in the timeline, it was just one of those things. It started off with like a 10 bead. It started off with a bunch of pebbles. And then somebody put it in a frame, and then in the frame there was like 10. It was 10 beads across, and then after the 10 beads, Chinese people came in and said, you know what, let's make it more efficient, and they came up with this. And then Japanese people came in and said, you know what, we can make it even more efficient, and then they came up with this. So now, if you look at it, there's a bunch of abacus competitions. They're using this. So there's this one to get the 2 bead away from the so there's a YouTube special. There was a YouTuber. She's a woman, and she was doing calculations in her head. Her method was abacus, and she was competing against Bill Gates, and he had a calculator. And when she was doing all of this stuff, like she wasn't even doing this, she was just imagining it in her head. She was imagining this abacus, the Japanese abacus, in her mind. And so from there, it's Soroban. So it's called Soroban. Can you demonstrate subtraction and then multiplication again? Yeah. Yeah. Do you have a specific question, or do you want to just just get something out? We could do this one. Oh, okay. Okay, so let's do Krista's first. Okay, Krista, That one's good too. So we do 13. Let's do this one. We'll do this one, and then we'll do the other one. I would like to see 2 because I don't know how to work, but it's cool. Hey, I'm bolted. Okay. Yeah. So the first thing I'm bolted, what we're going to do is we're going to, I need to write this down. 7 minus 30. Okay. So what we're going to do, I am bolted, is figure out how to read the abacus first before we start doing subtraction. So 1, 2, 3, 4. That's how we count. That's it. Anytime the beads are touching the horizontal bar, that's being counted. This is 4, this is 5. The top bead will always be 5. So we have 5, 6, 7, 8, 9. And that's it. But then what's 10? Well, you've seen 1 before, but now this is 10. Why? Because now we talk about place values. When we talk about the place values, we have ones, tens, hundreds, thousands, 10,000. So this is the ones, this is tens. So this is 10, this is 11, and then this is 12. 13, 14, and then 15. After 15 is 16. 16, 17, 18, 19, 20. Notice there's a pattern. So when we talk about the tens and the 20, right, this is 30, and then 40, and then 50. So you've seen it on this side. So this is 9. This is 90. After 90, right, is 91, 92, 93, 94. Here is 100. After the 100, this is 494. This is 5,494. Does that make sense? I'm volted. So the question is 13. So we're going to do 13. Now what are we going to do? What are we going to do? We are going to look at our abacus and realize we don't have enough beads to add, right? Thank you, Josie. I know how to count really well. It's just a running joke. I've been teaching abacus for 20 years. So I've been counting from 0 to 9 for 20 years. All right. So Krista, notice we don't have enough beads to take away 7. So after we take away the 7, what are we going to do? Minus the 7 is minus the 10 plus the 3. This is where we have two-step equation. Why? Because this 3 right here, I already know it. Though now what does that mean? So I'm going to take away the 10. But now we need to add the 3. There's not enough beads to add the 3. We know how to add the 3. It was one of our formulas that we needed to memorize. To add the 3 is just like plus the 5 and minus add the 5. So plus 3 is equal to plus the 5 minus 2. So we have plus the 5 and I take away the 2. This is a two-step equation because of this one right here. The reason why is because we don't have enough beads to add 3, so we have to utilize our 5. Now, our answer is 6. Did that make sense? Where can we buy an abacus like the one you're using? I sell this one off my website. I can't figure out how to make it onto TikTok Shop because I got to put in a children documentation. But if you go to my link in my bio, that's my my website, and then you could see this specific abacus that I sell. It's 7 columns, and it's made out of plastic, which is kind of cool. Link in the bio. Yes, thank you. Link in my bio. I don't see all of the comments, but thank you. I appreciate it. Thank you. Odd question. Is there any correlation with binary? I don't know binary. I don't know what binary means. Like ones and zeros? I don't think so. Because this is a 10 base. Because it's decimals. So this is 10 base. No, thank you, Rico. This is 10 base. Can we see you go as fast as you can for us to watch? Miss X. I could, but I don't know. Okay. I mean, we could do this one. So if but I do a lot of explanation, right? So if minus the 3 is minus the 5 and then minus the 2 and then that's the answer. That was easy. Oh, sorry. So that was the answer. What is the question? So we do 567, right? Take away 32. Take away 3. To take away the 3, I need to minus the 3 is equal to minus the 5 plus the 2. So I minus the 5 plus the 2. And then minus 2. Minus 2 is equal to minus the 5 plus the 3. So I minus the 5 plus the 3. And then 0. So my answer is 247. I don't know if that was fast. So Krista, did that make sense? Thank you, Melinda, for the question. That was a good question. Yeah. Miss X, I don't know if you wanted another question to go. It was, but it shows how much you break it down. Yeah. Okay, yeah. Yeah, I do, yeah. This makes sense too, right? So this is a two-step equation. And so that's the difference. The difference between these two is that you have your plus 10, you have your minus 10s incorporating the plus 5s. So that's why this is called a two-step. And it's the peek into a two-step equation like you do in algebra. And so I don't know if I've told you this, but like when my kid has gone through algebra, he's like, how come I know how to do algebra, but nobody's really taught me? And it's because he knows Abacus. He's gone through the Abacus curriculum, and with the Abacus curriculum, there's like sprinklings of algebra. And so that's when I started like thinking about what sort of math terminologies can I use when I talk about abacus? Because in abacus world, we don't talk about isolating the variable. We only talk about the formulas. So when we talk about the formulas, we just need to know plus the 4 is equal to plus the 10 minus the 6. And when we do this, it doesn't matter what column we're in. This just means the next column over. So it doesn't even matter if this is like, let's say we did this is, right? 400, I'm sorry, let's do, we're doing, okay, so we do 460, I'm sorry, let me get in more paper. Oh my gosh, okay, good. So let's do this one. We do 467 plus 349, right? When we add it. We don't talk about Bruno. Okay. There we go. So I'm not sure. I'm not sure if I'm missing a comment there. All right. So what we're going to do is we're going to do 4, 6, and then 7. So after this, we do 4, 6, 7. Now what we're going to do is we're going to add 3. When we add 3, how do we add 3? We add the 3 is plus the 5 minus 2. Notice I do plus the 5. I don't say plus 500 minus 200. That's too big. That's too much, that's a lot of numbers. So what we do is we focus on the actual column itself. What are we doing here? We're adding 3. When we add the 3, we just need to plus the 5, take away the 2. So we're very specific. 6, 7. Okay, right? So then the next one we're going to do 4. How do we add the 4? It was a play on something you said that we don't talk about something. Oh, yeah. I see. Focus on isolated column. Yes, correct. So now I'm going to add the 4. I'm going to add that into my little thing, Melinda. That's what I'm going to do it. Oh my God, that's funny. That's so funny. So I want to add the 4. I want to add the 4 here. I'm not adding 40. So in new math, we say add 40. But in Abacus, all we're doing is we're isolating the column. We only look at this, we want to add the 4. Well, to add the 4, what do? We have to, can we add the 5? No, the 5 is already used. So what do? Plus the 10 minus 6. So what are we going to do? Plus the 10 just means I'm going to go to one column over. That's it. That's all I'm doing. Plus the 10 just means one column over. So I plus the 10 and I take away the 6. I'm not going to say plus the 100 because then you get confusing because I don't know if I have to do 2 columns over or 1 column over. And then plus the 9. Well, I'm going to add the 9. How do I add the 9? I cannot add the 9 here. What do? I have to plus the 9 is equal to plus the 10 minus 1. Again, plus the 10 just means this, plus the 10. So plus the 10 minus the 1. And that's my answer, right? So it's interesting. Thank you so much, Ebony, for the rose, right? It's interesting on how it's just interesting on how new math, it sounds more complicated than it really is. The difference is, in Abacus, we do it on the Abacus. We work through the numbers on the Abacus, so we don't need to know how to add 40, add 300. We just need to work the specific columns and let the Abacus, use the Abacus for what it is. It tracks our numbers. Use the Abacus for the tool that it is. And it helps us with place values, and it helps us with our numbers. And it helps us see what numbers we can and cannot use. So if I can't use the 9 by itself, right? If I cannot use the 9 by itself, how else can I add my 9? That's it. So it adds to creativity as well. We have our pieces. Now, how do we supercharge our pieces? How do we make our pieces work for us? Because, just like child labor, I have boys, I want them to work, but they don't because they're lazy. But that's a different story. Anyways, so the answer is 800, 6. Hey, Jose. Does that make sense? Are we okay? So we're still on adding and subtracting. It's my allergies. Max asked how to read. All right. Okay. Max, how to read. 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, it's being counted. The top bead has a value of 5. 5, 6, 7, 8, 9. And then we have 10. This is 10. 1 and 0. Oh no, take a break. Ha! It's it's the allergies. The wind is starting to pick up again. So we have 11. This is 11. 1 and 1. And then we have 12. Hi, Kim. 12, 13, 14. Okay. Did that make sense, Max? And then Tar, where are you? It's not correct? This is not correct? Why is it not correct? We have 4, 6, 7. We have 3. We have 4. We have 9. No, that's correct. It is correct. Okay. You can count the beads that touches the bar. Yes. Okay, good. Oh, it's 7. Yeah. But don't forget. If I move my abacus, then my whole thing gets messed up. To say she's not correct is crazy. She does this. No. I am incorrect. I need to just double check. Because sometimes I forget what I'm doing. So, oh yeah, so Max, we're going to do, so if we did this, 2, And then we do this. This is 32. And then this is 82. Oh, noodles. No, it's okay. It's good to double check because remember there was what we were doing division and I'm like, "Oh, nah, nuts. This is wrong. I forgot to do it. It's been a while." Okay. So I'm okay with that. I'm okay with making sure it's correct. So Max, we're going to continue on. If we look at this, this is our ones, our tens, our hundreds. So we look at this is 82. After 82, it's possible that she remembers she has forgotten so much because it's been 20 years. Yeah. Or I just know how to count really well. So this is 82. If we did this is 400 because just as our place values are, we have 482. And then this is going to be 5. All the top bead has a value of 5. So this would be 5,000 because this is touching the horizontal bar. Because this column is the thousands, this is going to be 5,482. You can count to 10 and 10 and 10 exactly. 5,482. Does that make sense, Max? Wait, one fish, two fish, red fish, blue fish. I have to figure out how to do it. 1 bead, 2 bead, red bead, 4 bead. I don't know. 4 bead. I don't know. I have to figure that one out. There's a lot of things. Okay. Max, so that's how we read the abacus. When we understand how to read the abacus, then we can actually do some adding and subtracting. So that's what we were doing here. And I was just double checking. And so when we were talking about it, what we need to do is just understand that we're moving beads. So we have 2 and we're going to add 2 more beads. So all we got to do is just add these 2 beads. And that's just adding. We did a little bit of adding, if you notice, when we talked about 5. And we said, well, what's 6? Well, 5 plus 1 is 6. 5 plus 2 is 7, if you notice, because we have the 5 and the 2. And then we can count on. We have 5, 6, 7. So it all makes sense, right? And you notice if this is 7, this is also 7, but this is 77, and this is 777, and this is 7,777, and this is 77,777. Not that I like sevens a lot, but it is right there. And then this is my ones. So 1 bead, 2 bead, red bead, blue bead. Oh, yeah. Do another one. Oh, do another addition? Or wait. So Max, in my ones place, this is my ones. If I do here, this is my ones, but after the ones is, what's after the ones is your tenths. So it follows the same concept of how we write. So we have our tenths and our hundredths. We have 2.45. Or we can do 0.5, right? So this would be 2.5. Do another math question, or do another addition, or do another subtraction. This one? I don't know. We could do... Okay, we could do this one. 3, 4, 8, 2, 1, 7. Let's see that one. This is a plus. Am I going to do plus? I'm going to do plus. We can do minus. We can do minus or plus. Oh, can we try if... Yeah, we could do that. Oh, okay. We could do that. Let me finish this. So, 348. Plus 2, plus the 5, right? Whoa. So, plus 2 is equal to plus 5 minus 3. We do minus. Okay, we do minus. So, we'll do minus. Take away 2. Oh, that's too easy. Take away 1. Take away 7. Oh, that's too easy. That's too easy. Is your books different than Teachers Pay Teachers? No, it's the same book. Teachers Pay Teachers, I was trying to be more versatile. I think the book is more... updated. I think the book is more updated. Because there was a couple of... When I was working through it, there was a couple of questions that was like, that didn't make sense. Like, I think I updated the thing. I don't remember if I updated the teachers pay teachers one. But if there is any discrepancies, let me know, and then I can just update it. But yeah, let me know what you have. But yeah, if that's okay, you can help me go through it. But yeah, like this one. I don't remember if I changed this one. This one turned out to be a maze because this concept got too complicated for the students, so I changed it to something different. If that's okay, Krista. Yeah, let me know if there just the discrepancies. But I tried to go through it. I didn't. I tried to go through it, but hopefully it was okay. But yeah, the teachers pay teachers is supposed to be the same as this. But yeah, if that's okay. Okay, sorry. That was too easy. 131. Okay. Oh, so multiplication. Okay, if we did, are we talking about 1 times 4? So 6, 3, let's do 4, 7. Are we talking about this way or the other way? More than okay. Oh, yeah. Yeah, let me know if if you have any discrepancies. You don't know, or yeah, okay. Kim, do we want to do this way or do we want to do this way? Yeah. The difference is the steps. The first is easier. The first is not easier. Okay, let's do it. Let's do the first one. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, I don't have enough beats. 1, 2, 3, 4, 5. We're here. The first thing we're going to do is 2 times 6. 2 times 6 is equal to 12. So I add my 1, I add my 2. I choose 6. You choose 6. Okay. We're done with this. We got to reassess. 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to start here. 3 times 6. 3 times 6 is 12, is 18. Add the 1, add the 8. Yeah. So now we go backwards. So when we do it, we just go backwards. And again, 4 times 6 is 8. 6 times 4 is 24. So I add the 2. Cannot add the 2. What do I do? Cannot add the 2. What do I do? 1, 2, 3. 1, 2, 3. I need to add the 2 here, right? Because it's 24. Add the 2, add the 4. Add the 2. Cannot add 2. Plus 2 is equal to plus the 10 minus 8. I want to plus the 10. So I add the 10 minus the 8. Add the 4. Not minus the 3. Because we cannot add the 5 anymore. That's why. If the 5 is down, we cannot add the 5 again. We added the 4. Okay, we're done with this. Now we got to go here. 6 times 7 is equal to 42. Add the 4 plus the 5 minus 1, and then add the 2. Because, yes, exactly after the fact. Yes, Alex. Because the 5 is already used, we cannot use it again. We could use it again if you think about the more addition. What does that mean? So if we did 5 minus 3, let's say we did that, right? Well, what is plus the 5? Plus the 5 is plus the 10 minus the 5. So we're still going to plus the 10, take away the 5, and then take away the 3. My kid actually did that, and it was really kind of interesting. He was so versatile that he was able to take away the 5 and use that. But that's really advanced, I guess. That's really, I don't know if it's advanced, but it was just one less thing that he had to memorize. Yeah. So, yeah, if we stayed with the if we stayed with the plus the 5, then we would have to utilize that, if that made sense. Yeah. So our answer is, I lost my answer. I think it was 1,482. 1,400,082. 1, 2, 3, there, like that. That's what that is. And it's why is this easier? I don't know. I think this one is easier because it would be the same thing, but we wouldn't have to reassess. I think that's what it is. I think is we wouldn't have to reassess, because if we look at it, right, 6 times 2 is 12. 1, 2, 3, 4, 5. 6 times 2 is 12, right? Add the 2, add the 3. 6 times 3 is 18. Add the 1, add the 8. 6 times 4 is 24. Still the same thing. 24 plus the 10 minus the 8, add the 4. And then 6 times is 4, 42. So you put the comma in the wrong place. Oh, yeah, you're right. I did. Thank you, young thug. 14. Yes, you're right. 14,082. Thank you, young thug. At least somebody's paying. At least you have attention. You have attention to detail. Yeah. Okay. So does that make sense? You're right. I don't know. I think this is easier because I don't have to reassess. But we could do that. It's in multiplication is interchangeable, so it doesn't even matter. It's only the adding and subtracting that's not interchangeable, right? So if we add the 8 or we add the 5, it's very different. But if it's 2 times 3 and 3 times 2, it doesn't matter. It's all the same. Young thug. Funny. All right. Anybody have any questions? We're coming down. We're winding down. All right. Yeah. Anything? That was good. Yeah. It's interesting to see how math can work. But yeah, multiplication is pretty the same. Cool. Any other? Does somebody remember what this is? They had to use 4 5s. This is somebody's workbook. And again, I went to go through all of their worksheets and notebooks, and I realized, look, there's an empty one that I could use. All right, we'll do that. Okay. Hi, Irene. Do we have any more questions? Any more questions? S. Okay. What are we going to do? What are we doing? We can do division. Welcome, Bruce. Oh, here we go. All right. Okay. I don't know who else is here, but we can count. 1, 2, 3, 4. Or we could do some, okay. Right. Okay. 4. Because the value, oh, thank you, Robert. Let me finish counting and then we can do that. Division? Yeah, we can do division after we do multiplication. So 78 times that by 69. So this is 4, because we have the horizontal bar, this is 4, and then we have 5. Because we have the top bead, will always be a value of 5. After 5 is 6, 7, 8, 9, and then this is 10. Notice that this is 1, and we've seen it before. That's 10. This is 0, this is 1. This is 20, 30, 40, and then 50. All right, we are going to start doing some multiplication. So we count 1, 2, 3, 4. We have 4. We have four digits that we're going to count. 1, 2, 3, 4. What we're going to do is we're going to do 6 times 7. 6 times 7 is equal to 42. I add 4, I add 2. And then 6 times 8 is 48. I add 4. 2 plus the 4 is equal to plus the 5 minus 1. Because I'm adding the 4, right? So plus the 5, take away the 1. And then I add my 8. I now need to reassess because I'm done with the 6. So now I got to do 3. 1, 2, 3. 1, 2, 3. 6 times 7. I'm sorry, 9 times 7 is 63. Excuse me. Add 6 and I add 3. Add 6. There's not enough to plus the 6. Plus 6 is plus the 10 minus 4. Plus the 10. There's not enough to plus the 10. So what do? Plus the 10 is equal to plus the 10 again minus 9. No, minus, no. I want to plus the 1. To plus the 1, I need to plus the 5 minus 4. Because I have enough to add the 5. Plus the 5 minus the 4. And then here I have to minus the 4. Minus 4 is equal to minus 5 plus 1. Minus the 5 plus the 1. My next one is 8 times 9. 9 times 8 is 72. Plus the 7 plus the 2. Plus 7 is equal to, plus 7 is equal to plus the 10 minus 3. So I plus the 10 and I take away the 3. And then I add the 2. So my answer is 5,352. Okay. Division. Division. We'll do this one. So we have 644 divided by 2. Oh, good. No worries. No worries, Melinda. You're okay. We're okay. We're all here. So we're going to do division. Now, just like we did multiplication, we had to add our digits. But in division, we actually have to subtract our digits. Now, we have to also keep track of our dividend and our divisor. So our dividend is 644, and our divisor is 2. So the first thing we need to do is we need to figure out where our place value is. So we have 3 dividends. Take away 1 divisor is equal to 2. So we need to answer on the second column. So that means it's 1, 2. This is where our answer is going to start. So because our answer is going to start here, I'm going to put my dividends onto the abacus. Because what we're going to do is on the abacus, we're going to subtract it. So we have 6, 4, 4. Now the question is, who is bigger? We have our dividend or our divisor. Our dividend is 6. Our divisor is 2. So if our dividend is bigger, we only need to utilize one column. We skip one column and we subtract one column. Thank you, Melinda. So what does that mean? Because the dividend is bigger, we're only going to do 2 times what is equal to 6 or less. 2 times 3 is equal to 6. We still have dividends left. Thank you, Melinda. That's the 3. I'm going to look at the abacus. My dividend is 4. My divisor is still 2. Who is bigger? My dividend is still bigger. So what do I do? Thank you. So the question is 2 times what is equal to 4 or less? I'm skipping one column. I'm going to put it here. And I only need to subtract one column. So 2 times 2, thank you, Melinda. That's my 2. Take away 4. And then do it again. Dividend is 4. Divisor is 2. 2 times 2 minus the 4. So our answer is 322. Yes, 322. Okay, we can do this one. These ones are, this is what the kids would be able to do if they already know their multiplication math fact, right? So I'm working with the 3 times table and the 4 times table and the 2 times table. So even this one, right? We have 915 divided by 3. We can do that too. I didn't keep up, but it's because it's after minute. Oh, yeah. Okay, Krista. Yeah. Have a good night. Hey, Barbara. Have a good night. Yeah, it's getting late. Take a little breather. I'll see you in my next live. Thank you for joining. I'm happy you were able to keep up. Have a good night. Okay, so the first thing we're going to do, again, is to figure out our place value. So when we look at it, we have 3 over here and 1 over here. So 3 take away 1 is equal to 2. We're going to lock, and I think this will be it. Hello, Barbara. How are you? Okay. So, we have our divisor and our dividend. Our dividend is 9. Oh, can't see it. Our dividend is 9. Our divisor is 3. Who is bigger? E. Yes. Our dividend is bigger. So we need to actually put our thing there. 1, 2. And then we have 9, 1, and 5. Because our 9 is bigger, we need to skip this column and our answer is going to be here. And we're only going to take away the one column. So 3 times what is equal to 9 or less? 3 times 3. Yes. So 3 is equal to 9. We take away the 9 over here. Now what do? Who is bigger? 1 is our dividend. 3 is our divisor. Our divisor is bigger, so we need to utilize 2 columns, 2 digits. So because we have 2 digits that we're going to utilize, the question is 3 times what is equal to 15 or less? 3 times 5. So I'm going to put my 5, and I take away 15. Take away 1, take away 5. So my answer is 305. that's it. Wow, there's still 18 people in the room. All right. Does that make sense? All right. Whew, that was a good one. Whimsical Faith, welcome. I think it's time for me to sign off, though. I'm getting a little bit tired. Hello! Hello. Thank you, Robert, for joining. Always the silent one. I see you, Robert. Have a good night, Barbara. Thank you. Hey, Caleb. You came back or you left? Not sure. Hello. User 24. That's all I see. User 24. All right. If there's no other burning questions, I will sign off and we'll see you in the next one. Got on too late. We'll watch again tomorrow. Yes, for sure. I will be looking out for you. Thank you again. No, thank you after the fact, Alex. Yes, it was great. Yeah, as long as it makes sense. The biggest thing is, stepping into the questions and making sure we understand it. But when we understand it, it gets pretty fun. So, but my kids hated it. My kids hated it. But anyways, that's why there's more joy when I talk to you guys because you guys are excited. My kids were like, no, I don't want to do math anymore. But anyways, thank you again. Have a good night, everybody. And I will see you in my next live. Toodaloo, kangaroo. Thank you, Robert. Thank you so much. This time I didn't make too many mistakes. All right. Have a good night. Have a good night. Bye.